Cursor IDE agent, repository scale edits, and developer reports. Cursor is an AI-native code editor, a VS Code fork designed to manage entire code bases with built-in artificial intelligence. Unlike basic autocomplete tools, Cursor's agent mode lets the AI act in the driver's seat, reading, editing, and creating code across multiple files at once. In this mode, the AI can search your code, update imports, change function definitions everywhere they appear, run build or test commands, and fix errors in a loop, much like a senior developer working in parallel. It truly works at repository scale. For example, one guide describes telling the AI, add JWT authentication to this Angular app, and watching it create services, update components, run tests, and repair errors without manual edits. These agentic features are powered by a tool use architecture. The AI can call functions like read file, edit file, search files, or even run terminal command to inspect and modify your project. In practice, Cursor's agent can autonomously carry out large refactors and feature builds by combining language understanding with direct code manipulation. Cursor provides multiple modes of interaction. The most powerful is Composer, multi-file agent mode, which lets the AI read, create, and rewrite blocks across many files in one operation. In agent mode, you open a chat-like Composer window, tell it your goal, and it iteratively plans, acts, and checks results. The agent will, for instance, locate all relevant files for a change, apply consistent edits, run your project's tests or build tools, and circle back if errors arise. Each step is versioned with checkpoints, so you can review and roll back any changes. Teams often use Cursor's rules system to guide the AI. Simple markdown-based rule files, .cursor/rules, describe project conventions, coding style, architecture patterns, etc., so the agent writes code that matches your standards. This combination of rules, semantic indexing of the repo, and tool use is what enables Cursor's agents to handle repo-wide tasks intelligently. Agents for planning and execution. Beyond ad hoc edits, Cursor offers plan mode and background agents to organize complex work. In plan mode, you describe a high-level goal, and the AI will ask clarifying questions, outline a step-by-step plan, and then execute those steps only after you approve them. For example, the AI might propose breaking a large feature into subtasks, ask about assumptions, and then run each step in sequence. This helps avoid the pitfalls of giving one huge vague instruction, which often leads to errors, by keeping the AI aligned with your intent. Cursor also supports cloud agents and multi-agent workflows. Each agent runs in its own environment, e.g. a separate Git work tree or even on a remote server, so you can have multiple AI workers tackling different parts of a project in parallel. One report notes that Cursor can spin up to 8 agents simultaneously for a refactor. These agents even have tools like a browser. One demo shows an agent opening the built app in a browser, clicking through the UI, and recording a quick video to demonstrate success. In practice, Cursor claims over 30% of merged pull requests at one company came from these automated agents. Whether in agent, chat, or edit mode, Cursor's AI works in a loop. It observes the current project state, plans the needed changes, acts by writing code or running commands, then evaluates results, including test or build outputs, and iterates until it succeeds or needs human input. This is a key difference from many chat-based coding assistants. The agent has direct access to your code and tools, so it can execute commands like npm install or git diff and immediately see the outcomes. For example, if the AI introduces an error, it will read the compiler/test output and try to fix it, rather than leaving the error for the developer to catch. This tight integration of planning, execution, and verification makes Cursor's agent mode uniquely powerful for repo-wide changes. Developer feedback, code quality, diffs, and testing. Users generally report that Cursor's AI writes context-aware code that matches project patterns. But like any AI-generated code, it still needs careful review. Guides emphasize that large or vague prompts can lead to mistakes. It's usually better to split big tasks into smaller, testable steps. In practice, Cursor provides diffs of the proposed changes and encourages developers to review them thoroughly. For multi-file edits, the system shows an aggregated diff view. You can click into each agent's set of changes and see exactly what was added or modified. The AI creates checkpoints for each agent run iteration, so you can roll back any part of the refactoring if something looks wrong. A common user recommendation is to accept changes agent by agent and then run tests immediately. For example, one tutorial advises, review diffs carefully, accept changes from one agent at a time, test those files before moving to the next. This reflects the sentiment that Cursor's edits are powerful but not flawless. Indeed, one example cited a rename of a prop in 50 components where Cursor missed some files, the ones implicitly imported through an index file, requiring the developer to manually add those to the context. That study suggests Cursor's pattern-based analysis can occasionally miss indirect references unless the prompt explicitly includes them. On the upside, many users find Cursor drastically speeds up refactors and multi-file tasks. For instance, a developer reported cutting a 2-day refactor, 150-plus files, down to 20 minutes with multi-file edits. Review surveys, e.g. on G2, note that a large majority of Cursor users say multi-file refactoring is now a top reason they use the tool. However, they also stress vigilance. Always commit before running the agent, test after each batch, and remember that AI doesn't understand your business logic the way you do. In practice, teams run their test suite after agent edits and fix any broken tests, treating the AI as a helper that speeds up work but still requires human oversight to ensure correctness. Regarding diff granularity, Cursor's multi-agent system actually gives very granular control. Each agent works on a subset of files with its own workspace, and you can view or undo any agent's changes independently. The final diff is organized by agent or by file, so you can see exactly what changed in each part of the code. This is in contrast to tools that generate one giant change set. As one developer observed, Cursor's approach keeps your main branch untouched until you approve, and errors in one agent's work don't wipe out others. Sentiment on code quality is cautiously optimistic. Cursor generally produces logically consistent code that follows project conventions, especially if you use rules, but it can still introduce logical bugs or subtle errors. That is why developers emphasize code review and testing after each batch. The combination of AI productivity gains with required human QA is a recurring theme. Users appreciate how fast it can work. For example, editing documents in the blink of an eye compared to watching Copilot type line by line. But they also report so many bugs in early releases and stress the importance of approving or rejecting the suggested changes. This mixed feedback suggests the AI's output is generally useful, but not flawless. Known limitations and best practices. While Cursor's agents are powerful, they have limits. One major constraint is scale. Handling very large monorepos, hundreds of thousands of files, can overwhelm any tool. A widely cited user guide explicitly warns that trying to refactor a codebase over 100,000 files at once is inadvisable. The dependency graph gets too tangled, and agents trip over each other. For such massive projects, the advice is to scope changes to smaller subsets, folders, or chunks, rather than a single global command. Cursor's own documentation suggests techniques like indexing only parts of a repo, excluding irrelevant folders, and breaking work into smaller chats or plans. Another limitation is binary or non-code assets. Cursor's AI and semantic search work on text, source code, configuration files, documentation. It will generally ignore images, videos, or compiled binaries when planning changes. In practice, this means you cannot ask Cursor to say add a watermark to all PNG images in your repo. It simply doesn't parse or edit binary formats. In other words, any repo-wide change must be about code or text, functions, comments, config, etc., not arbitrary files. This is why users focus on tasks like renaming code symbols, updating code patterns, or generating files, not tasks involving non-code assets. Complex build systems and custom environments can also pose challenges. Cursor can run commands like npm test or make in the terminal, but it only knows the output it sees. If your build requires multiple steps, custom scripts, or proprietary tools, the agent might need guidance. For example, if a project uses a multi-stage Docker build or an unusual toolchain, the agent may not automatically handle it. In such cases, you should feed the agent enough context, for instance, listing build steps in your prompt, or rules, and plan smaller steps. In general, Cursor works best when your code is in text files on disk and can be built tested from the CLI. Very intricate build pipelines might require iterative prompts or even manual intervention. In summary, what this means is, Cursor shines on well-structured codebases where changes follow clear patterns, e.g., updating imports, refactoring common code idioms, or adding boilerplate components. It is less suited for tasks that involve hidden or implicit dependencies, like an object graph connected only by runtime behavior, or components registered dynamically, or for non-code data. The best practice is to treat Cursor as a supercharged copilot. Use version control, commits and branches religiously, run tests frequently, and stay involved in the loop. As one guide puts it, use it like a senior engineer who's great at rote work but still needs a second pair of eyes. Comparing Cursor, Copilot, and ChatGPT. When comparing Cursor to other AI coding assistants, key differences emerge. GitHub Copilot and its agent modes and Cursor are both AI-powered, but they take different architectural approaches. Copilot is an extension that integrates into existing editors, while Cursor is a standalone AI-native IDE. Cursor's tight integration lets it index and embed the entire repository, giving it architectural-level understanding of your project. Indeed, DataCamp notes that Cursor indexes your entire codebase so it can reason across all your files by default. Copilot, on the other hand, traditionally only sees open files and relies on GitHub search for broader context. Copilot has recently added more repository indexing via GitHub code search, but observers say Cursor still has the edge on large projects due to its full IDE control. In practice, this means Cursor can handle multi-file and cross-service refactors more directly. In Cursor's agent mode, a single command can edit dozens of files at once and update imports or tests consistently. Copilot now also supports multi-file changes in agent mode, but it tends to be more manual. Typically, you select which files to change and step through them one by one. Copilot also offers a separate GitHub-hosted coding agent that runs asynchronously to open a pull request with changes. You delegate an issue on GitHub and come back to review the PR later. Cursor's equivalent is to use its background agents or hooks to generate PRs. But the key point is Cursor's workflow is real-time and in-editor with fine checkpoints. For code completion and immediate suggestions, Copilot's deep integration means it works in any supported IDE, VS Code, JetBrains, etc., with fast inline ghost text suggestions. Cursor also offers inline completions using its own tab model, but its real strength is beyond one-line auto-completion. Both tools now support advanced agent modes. Cursor's design encourages bigger plan tasks. It has a built-in plan mode, and its default interaction is to have the developer in the loop while the agent executes. Copilot's design emphasizes continuous coding with occasional delegation. You get autocomplete and chat help all day, and for a large feature, you typically kick off an agent or Copilot chat and return later. As for code quality and reliability, both tools are improving, but neither is perfect. In one comparison, Cursor was noted to produce reliable, context-aware changes with checkpoints. Yet community reports have surfaced occasional checkpoint failures and unwanted rollbacks. Copilot's changes rely on Git branching and PR workflows, which some teams find more familiar. Cursor boasts features like automatic rollbacks and multi-agent diffs, but users should test those features thoroughly in production. Conversely, Copilot's agent mode also generates changes, but developers often rely on their existing code review process for safety. Finally, comparing to traditional chat assistants like ChatGPT, the difference is stark. ChatGPT, or Claude Code in chat interface, is a general chatbot. It only knows what you paste or describe, and it cannot write into your files or run your tests itself. Cursor, by contrast, is built for coding. It has full codebase awareness and can directly manipulate files with no copying and pasting. The low-code guide puts it simply. Using ChatGPT for coding typically means manually copying code in and out of the chat, whereas Cursor preserves your workflow within the IDE. This makes Cursor much more efficient for iterative development. In summary, Cursor versus ChatGPT. Cursor is an AI-powered IDE that can edit your codebase in place, understand project architecture, and perform multi-file edits. ChatGPT is a general assistant you talk to, with zero built-in knowledge of your files. You must paste code into it. For repository-wide refactors, Cursor wins because it integrates natively with your project. Cursor versus GitHub Copilot. Copilot is a widely used AI assistant embedded in many editors, and Cursor is focused on a real-time, in-IDE workflow with advanced multi-file editing and contextual awareness. Great for inline suggestions and quick coding help across tools. Cursor offers a more all-in-one experience for deep, multi-file coding tasks. Cursor's Agent Mode Composer can update many files at once with checkpoints, whereas Copilot's Agent Mode changes files one at a time or via pull requests. Copilot benefits from broad IDE support and official enterprise features, but Cursor emphasizes raw power for complex refactors through parallel agents and richer context. In practice, teams choose Copilot for general coding assistance and compatibility, while Cursor is chosen when deep architectural code understanding and large-scale edits are required. Conclusion: Cursor's agentic features bring a new level of automation to coding. By treating the AI as an autonomous assistant with file system access, multi-step reasoning, and planning capabilities, Cursor lets developers perform repo-wide edits, migrations, and tests much faster than manual work. Users report dramatic time savings. One cited a 90% reduction in a refactoring task, though these gains come with the responsibility to review AI output carefully. In short, Cursor's AI agents can transform large, repetitive coding chores into manageable workflows, but they require clear instructions and human oversight. For teams struggling with sprawling code bases, Cursor can be a powerful productivity multiplier, as long as it's used with cautious checkpoints and robust testing. Whether Cursor is the right tool depends on your project. If you need deep, cross-file intelligence and can migrate to a new IDE, Cursor offers specialized capabilities beyond typical autocomplete assistance. If you prefer staying in your current editor and working incrementally, GitHub Copilot or other chat-based tools may be more convenient. The future of coding appears to be one where AI agents like Cursor complement human developers, handling the tedious plumbing and letting programmers focus on design and strategy. As one expert notes, the future of coding isn't about writing more code, it's about changing less of it. And Cursor, when used well, lets you do exactly that. All links to sources are available in the text version of this article. You can find the full article at easycoding.tools. Thanks for listening. For more practical AI coding guides, tool comparisons, and resources for builders, visit easycoding.tools. And if it's easier to remember, just go to aibuilds.it. It redirects to easycoding.tools.